In this video, we'll learn about Arnold Volume and how to work with OpenVDB files. Before starting this lesson, I want to show you a few resources to download OpenVDB file. First is openvdb.org/download, and if you come down here, they have these sample models. Go ahead and download these 4 files: Explosion, Fire, Smoke 1, and Smoke 2, and extract them into a folder on your hard drive. You can access these OpenVDB files and bunch of other files in the project files folder for this course. I'll be using this Smoke 2 file later on in the lesson. Also, if you go to jangafx.com and using this downloads menu, go to this free VDB example page, you can download 6 of these VDB animations. I'll be using this gasoline explosion throughout the video. Just go ahead and download at least this one. It's not a very high quality explosion simulation in terms of voxel details, but it would be enough for this lesson. I'm in this empty scene for now. First, I want to make sure I'm working with a properly scaled scene, as this explosion file is fairly huge in terms of its size. So press Ctrl D to open up the project settings and change the project's unit to meters. To load an OpenVDB file, first you need to create an Arnold Volume object from the Arnold menu. So let's add one. Now from the OpenVDB tab, load the OpenVDB file. Just go to where you have saved out the gasoline explosion VDB file from JangaFX. Select the first frame and press open, and that would be enough to load the OpenVDB sequence. Now if I add a simple Arnold sky and move to frame 70 or something like that and start the IPR, you can see we have our gasoline explosion. We just need to rotate it -90 degrees on Y, and we can move around a bit, and there you have it. So you can use Arnold Volume to load volumetric files stored in formats such as OpenVDB, which is an open source library developed by DreamWorks Animation, and it is capable of efficiently storing and manipulating volumetric data. Here I just want to show you the workflow and how to use OpenVDB files in Arnold, and hopefully make you more interested in the subject, and maybe you can learn how to create OpenVDB data in softwares like SideFX Houdini. Now let me go back to my main scene. In this scene, I have already loaded that gasoline explosion VDB file into an Arnold Volume, and I have some basic light and camera setup as well that you can check them out on your own. Let's run the IPR, and let's go to maybe frame 60. Or maybe 55. You notice I haven't applied any shader to this Arnold Volume object. By default, the volume has a standard volume shader applied to. We can assign our own standard volume shader later on to this volume and adjust the look as we wish. But before that, if I select the Arnold Volume and go to the OpenVDB tab, in the available grids list, we have all the available channels that this OpenVDB file has. In this case, density, temperature, and flames. And this grids drop-down menu is set to all, which means all of these grids or channels that come with this OpenVDB file will be available in the shading context. You can change it to custom and only make the grids you want available. Right now, because just the density channel is available in the shading context and the temperature channel is not, we only get the smoke and the fire is gone. I can add the temperature manually here. And this will make the temperature channel available as well. In a moment, I'm going to show you how to use these channels to modify the look of your fire and smoke. In the velocity grids field, you can specify the velocity field to be used for motion blur. It could be one vector grid. In that case, you would enter V or vel for velocity, or it can be 3 float grids like here. We have velocity scale, which is a scale factor for velocity field. As you are increasing it, you are gonna have more motion blur, and at 0, you disable motion blur for the volume. And that is in case the OpenVDB file came with a velocity channel, which this OpenVDB does not have. If you make your own OpenVDB sim, you can opt to export velocity data as well to be used in motion blur later on when rendering. Let's create our own standard volume shader and assign it to the volume. From the material manager, let's create a new standard volume shader. and assign it to the volume. As you can see, we get the same result because, as I mentioned when creating an Arnold volume, a default standard volume shader will be applied. But now that we have our own standard volume shader applied to the volume, we can start adjusting it. So let's open up the standard volume shader and take a quick look at the volume, at the standard volume shader and the most important parameters here. So standard volume is a physically based volume shader. It provides independent control over volume density, scattering, transparency, and emission components. Each component can be controlled by a volume channel coming from the volume object, with other parameters acting as multipliers on the channel. Simply put, density, scattering, and transparency components control the look of the smoke, and the emission component controls the look of the fire and the heat. So for now, let's set the emission intensity to 0 and focus on density, scattering, and transparency components. Density controls the density of the volume, with low density resulting in thin volumes and high density in thick volumes. So if I try something like 0.01 or 0.05, we get a very thin volume, and if I try something like 5 or 10, we get a very thick volume. Let's set it to 1 for now. You can use this channel field to define the density channel to read from the volume object. By default, it is set to density, but if the particular OpenVDB file that you are working with comes with a different naming convention, just type the name of the channel that corresponds with the density channel here, or you won't be able to render it properly. Scattering intensity controls the brightness of the volume under illumination. As I'm using lower scattering intensity values, we get darker and darker smokes. Scattering color controls the color of the volume under illumination, and this is the color of your smoke. You can try a few colors here. Or you can use a volume sample node in conjunction with a ramp RGB node to get a range of colors throughout. I'll show you later on in the lesson. For now, let's use the default color and set the scattering intensity to around 0.25. Anisotropy controls the directional bias or anisotropy of the scattering. The default value of 0 gives isotropic scattering, so that light is scattered evenly in all directions. Positive values bias the scattering effect forwards in the direction of the light, while negative values bias the scattering backward toward the light. For now, let's set it to 0. Transparency gives you an additional control over the density of the volume to tint the color of volume shadows and objects seen through the volume. So if I use a lighter gray, the volume becomes more transparent. Let's use something like a pink color here, which you can see throughout the more shadowy and thicker part of the volume, and the thinner part takes on the complementary color of the defined color. Transparency depth controls the depth into the volume at which the transparent color is realized. Let's try 0.5, 1, 2, 5, maybe 10. Let's reset the transparency values to default. And now let's add some burning fire, folks. So let's set the emission intensity back to 1. We have emission mode, which by default is set to black body, and in this mode the volume emits color and intensity based on temperature for rendering fire and explosions. Black body emission is used to render fire and explosions directly from physics simulations, and by default it gives you these natural looking colors, but we also have other modes. I can change it from black body to density, and now the density channel is used to control the emission. And in this case, I can change the emission color to like an orangish reddish color, or we can change the mode to channel and specify the channel that we want to use. In this case, it's going to be temperature for us. And now it is taking the temperature channel from the OpenVDB file into consideration. Now, if you want to customize the fire color with a gradient, you need to open up the shader network editor. First, load the volume sample RGB node, which allows you to sample different channels or grids from your OpenVDB files. In this case, we want to sample the temperature channel from the file. So type in here, temperature in this channel field. Now add a ramp RGB node. Use the output of the sample node as the input for the ramp RGB node and connect the ramp RGB node to the emission color. In the ramp RGB node, we can create our own gradient or load this Flame 1 preset. And now we get this look that is fairly realistic. Obviously, you can go ahead and customize the color as you wish. But for now, let me just disconnect this ramp RGB node and change the emission mode to black body and reset the emission color to the default white color. Emission intensity decreases or increases the emission strength. Emission color controls the emission color in other emission modes, but when the mode is set to black body, this can be used to tint the overall color of the black body emission. I can use a blue color or a saturated orange color as a tint to the overall color that is produced by the black body emission. Cool, for now let's use white. Emission channel in channel emission mode controls the emission channel to sample the emission rate from, as we used it a few moments ago. Then we have specific settings for black body emission. Black body temperature acts as a multiplier for the black body Kelvin temperature value. Set it to 1 for now. Black body channel is the temperature channel to read from the volume object that will be used by the black body emission color, which is normally temperature or whatever that is correspondent to temperature channel in the OpenVDB file that you are working with. Kelvin controls the Kelvin temperature for the emission. Let's try a few values here. So the higher the value, the more hot the explosion will be. Let's use the default 5000 for now. And finally, intensity controls the intensity of the black body emission. For now, let's set the emission intensity under the mode dropdown to 3. Down here in this advanced section, you can use this displacement input to connect a noise texture or other black and white textures to displace the volume, similar to displacement on surfaces. Now, to clean up your volumes, make sure your lights in the scene have enough volume samples, and having low volume samples for your lights is one of the main reasons for having noise, especially when you are working with kind of lighter, brighter volumes like white or light gray smoke. So make sure to increase the light volume sample in those cases, because the noise would be very obvious. If you want to have multiple scattering in your volume, you need to go to render settings under the ray depth section and increase volume ray depths. Let's set it to 0 for now and take a snapshot. So this is with volume ray depth set to 0. Now set it to 2. Take another snapshot. And now if you compare this render to the previous one, you notice the emission scatters in the volume a bit, which makes it more realistic. Now, to make the multiple scattering more clean, you need to increase volume indirect samples, which controls the number of sample rays that get fired to compute indirect lighting of the volume. So to reduce noise when you have more than 0 volume ray depths, you need to increase the volume indirect samples. For now, let's set the volume indirect samples to 2 and volume ray depth to 1. Let's get back to those volume sample nodes. I'm gonna open up the shader network. Under volume nodes, we have volume sample float and volume sample RGB nodes. Very similar in functionality, but the float type has a float output and the RGB one has an RGB output. Let's drag a sample RGB node for now. Now you need to define the channel from the OpenVDB file that you want this node to sample and then pass the information. In this case, let's type density and connect the output to the density input of the standard volume shader. I'm going to set the blackbody emission to 0 so we can focus on the smoke. You can use the sample nodes to color correct the voxels that make up the volume. Here you have gamma, contrast, exposure, and so much more. When I say color correction, I don't mean that 2D regular color correction as we are sampling the density channel here. We are adjusting the density information that each voxel has and therefore modifying the final look of the smoke. For example, if I decrease the exposure, the smoke will become less thin. And if I increase it, it will become thicker because we are adjusting the density channel that makes up the smoke basically. I can decrease the gamma to make the voxels that have lower density values disappear, or increase the gamma to make them more apparent. I'll let you play around with these parameters on your own time. For now, let's disconnect it from the standard volume node. I have this gasoline underscore 02 standard volume shader. Let me assign it to the explosion volume and open up its network. For the density, I'm using this volume sample RGB node with a keyframed exposure value. Exposure is set to -2 up until frame 40, and that would make the smoke so thin and barely visible. At frame 55, the exposure is set to 0, so we get the full density of the smoke. And this way at the start, when the explosion begins, we don't have much smoke, and slowly we add more and more smoke. For the scattering color, I have used this kind of dusty color to make it more interesting. The blackbody Kelvin temperature is set to 4200. And I have used this pale yellow to tint the blackbody emission, which gives us this realistic shader. Looks really nice. Now let me show you how to create some colorful smokes. I'm going to hide the gasoline explosion and unhide this smoke VDB, which references this smoke puffy OpenVDB file that was taken from openvdb.org. That was this smoke2 file on the website. I have a few simple shader for this smoke. Let's assign this dark smoke shader. Which gives us this very dark smoke shader. If I open up the shader, you can see density is set to around 10 and scattering is set to 0.05. And that's it. There is this smoke gray shader, which is much lighter, with density set to 5, scattering intensity is 1, and scattering color is this mid gray. Now, finally, let's apply this smoke colorful shader. And open up its shader network. Now here density is set to 10, and the parameter that controls the color of the smoke obviously is scattering color. And for this to work, we have a volume sample RGB node that samples the density channel from the file. We have used it as the input for the ramp RGB node, which colorizes the density channel using this gradient that we have, and this was used as the scattering color for the standard volume shader. Let's select the volume sample RGB node, and we can play around with different values. Let's try gamma. I'm going to try 1, 1.2, 1.4, and 2. And now we're basically using the right side of the ramp RGB node. I'm going to add a pink color before the red color. And just add more of pink to the base of the smoke. It's really fun to work with these colors and create some cool stuff. I'll let you do that on your own time. For now, let's delete this pink color and set the gamma value to 1.4. As I mentioned, in this type of brighter volumes, the noise is more apparent. Just make sure to increase the volume samples of your lights to make the final render much cleaner, and that would obviously increase the render time. In this case, we need to use something like 5 or 6 light volume samples to get a clean result. Check out the finished version of this scene for some more colorful shaders and some simple smoke shaders as well, and also the renders folder where I will save out the renders from this lesson. Let me stop the IPR for now. One last thing I want to talk about is the Arnold Mesh Volume tag, which allows you to turn any object to an Arnold volume. Let's add a torus and place it in front of the camera. Assign a mesh volume tag, and now it's a volume. So in this video, we learned about Arnold Volume object and standard volume shader. See you in the next video, probably to wrap up the course.